In this session, we'll talk about methodological and statistical artifacts. When you hear the word artifact, you might think of objects that are of cultural or historical interest. Here, though, we're going to talk about an equally interesting type of artifact, namely research artifacts. So that is something that is observed in an experiment that is not naturally present, but that occurs as a result of the preparative or investigative procedure. When findings from a particular study are deemed to be, at least in part, the result of the particular research technique employed, rather than an accurate representation of the world, they are referred to as a methodological artifact. And a statistical artifact refers to an inference that results from bias in the manipulation or analysis of data. So, as a consequence of these research artifacts, findings do not reflect the real world, but they are an unintended consequence of measurement error. We will talk about floor and ceiling effects, absolute versus relative differences, and the speed versus accuracy trade-off. Floor and ceiling effects. These effects are sometimes referred to as scale attenuation effects, and they occur when the tests or the scales that we're using are relatively easy or difficult, such that substantial proportions of individuals obtain either maximum or minimum scores. And that means that the true extent of their abilities can't be determined accurately using this measure. Floor effects refer to when performance is close to the bottom of the scale, so the test or the task is too difficult. And ceiling effects occur when performance is too close to the top of the scale, so the task is too easy. And these things can cause problems in data analysis. As an example, looking at ceiling effects, if we had a study where we wanted to explore the role of sleep deprivation on cognition, perhaps hypothesizing that not getting any sleep would result in worse cognitive performance, and we might want to measure this by having some participants sleep normally and some people who have to stay up all night, and we want to compare the performance on a basic maths test. If the test is too easy, so that most people can get 100% despite severe sleep deprivation, that might mean that participants in both groups are performing close to 100% accuracy. So that might be a test of 1 + 1, 2 + 2, for example, which in most adults would be manageable even if you haven't had a good night's sleep. So if you were using this too easy measure, that would mean that the comparison isn't really that meaningful, because the hypothesized detrimental effect of sleep deprivation on cognition or maths performance, it could still exist, but it would just not be noticeable in this test. And on the other hand, if the test is too difficult, including maths problems that most people have no idea how to solve, performance might be close to 0% in both groups. In that situation, the hypothesized detrimental effect of sleep deprivation on cognitive performance might still exist, but it would not be noticeable when using this test. Studies with near ceiling or near floor effects in both key experimental groups or conditions are rarely published, because as you could see in the previous examples, it really doesn't tell us very much at all about the hypothesis we were trying to test, unfortunately. But you might find some papers in which one condition or the performance of one group seems to be quite close to floor or ceiling. If we have an intervention group that performs close to ceiling level and a control group that performs significantly worse, like you can see here, that means that the true effect so that is the difference between these two groups, might be even bigger than what we can observe in the study, but it's still reasonable to assume that there is a difference between these two groups. So this is an example of a less problematic scale attenuation effect, because we can still get some information about this key comparison between the two different groups. In this scenario, on the other hand, where we have an intervention group that is close to ceiling and we don't find a significant difference between the intervention group and the control group, we can't really be sure whether the ceiling effect is hiding a true difference or whether there actually is no difference between the two groups. So this is a more problematic scale attenuation effect, because we're not really closer to the answer of what is the difference between these two groups than we were before we conducted this study. Scale attenuation issues can produce fake interactions. So if you imagine a study in which you're comparing two different groups of participants, so children versus adults, and you want to test whether a power posing intervention improves their confidence. So looking at some example data here, you can see that in children, there doesn't really seem to be a difference in confidence levels between the condition when they were doing the power pose versus the control condition. But in adults, we see what seems to be quite a big difference. However, as you might have noticed here, one group, specifically the children here, seem to be performing very close to the ceiling in both of these conditions. And the effect of this intervention might therefore be attenuated and hidden in this group. But if we analyzed these results statistically, it's quite likely that we would find evidence for a significant group by condition interaction, which does not necessarily exist in the real world. So if we found this significant interaction and concluded that power posing is more effective in adults than it is in children, that might not necessarily be the case, because the children here were just always at peak confidence, and we would need to use a different measure where we can get some more variation to actually measure the effect of power posing in this group of participants. Average scores of exactly 0% or 100% would be quite uncommon. And note that if you have a task with two different options, 50% accuracy levels would actually equal floor performance. So if you only have two options to choose from and one of them is always correct, then even if you are guessing, you are going to score at around 50%. And similarly, if we have a scale that ranges from 1 to 7, it would probably be quite uncommon for all of your participants to use one of these extreme options at the bottom or the top of the scale. It could be the case, but typically the questions we asked are designed to get a bit of a range. And different researchers may disagree about what exactly counts as near floor or near ceiling performance. These debates can be quite heated, but I would say that if you're looking at proportions, scores that are within 5 or potentially 10 percentile units of floor or ceiling would often be seen as being near floor or near ceiling performance. So for example, if the average performance is 90% accurate, or definitely if it's around 95% accuracy, that is a cause for concerns regarding potential ceiling effects. But the basic thing you want to consider is to think about, in this specific task, in the specific measure, how many of the individuals were very close to either the bottom or the top of the scale. So in this case, how many people in at least one of the conditions got basically all of the questions wrong or all of them right. And if that is a substantial proportion of your participants, that also is a sign that floor effects or ceiling effects might be causing some issues. How can we prevent these issues? So if you are collecting data for a new study, you might do a pilot study, so including a smaller sample to get an idea of performance levels. So if you test your study out with, for example, 10 participants, and you notice that they are performing close to floor or ceiling, you might change your task to make it easier or harder before you collect data from a really big group of people. So that's something you might see researchers do. They might not always even report that in the paper, but that is one way to prevent these issues. If you've already collected all your data, you might try to exclude participants who perform under or over a certain level and redo your analysis without these participants. And if you find the same main result, that might be reassuring that the effect wasn't driven by floor or ceiling effects. Or you might have to replicate the study and make it easier or more difficult if these effects were really preventing you from answering your question. Next, we'll talk about absolute versus relative differences. So would you say that a price change from £1,050 to £1,000 is the same or equivalent to a price change from £100 to £50? So obviously, yes, if we're talking in absolute terms, the difference is £50. So that is the same in these two scenarios. But if we're looking at this in relative proportional terms, there is a big difference in that this change proportionally is a lot smaller in the first example than it is in the second example. So a reduction from 100 to £50, if you are buying something, that would be a 50% price reduction, which would seem like a much better deal and like a much more meaningful difference to a lot of people. And if we're thinking about this in relation to psychology research, and if we're comparing two different conditions in which memory performance drops from being able to remember 8 letters in one condition to 6 letters in the second condition in a group of younger adults, and we have a drop from 2 letters to 0 letters in older adults. This is a very extreme example just to illustrate the differences. The absolute difference is 2 letters and 2 letters, so these two things seem equivalent, but the proportional drop is a lot smaller in the young adult group, and in this specific extreme scenario, this drop seems to lead to a complete breakdown of memory in one group, in that they do not remember anything. So they are actually performing at floor level in this condition. And this type of change might also lead to a change of strategy, because there's a big difference between remembering something and remembering absolutely nothing. So both absolute and proportional changes can be important to think about, especially when you're comparing two different groups where the baseline isn't equivalent. And as another example of this, if we think about a study where we have two experimental groups and participants receive either £5 or £30 for participating, and this might be because some of them had to travel to participate, or some of them did a longer study, or this might be an experimental manipulation, and we're interested in the dependent variable of generosity, which is operationalized by their donations to charity. So what do you think would be the better measure here? Would it make more sense to look at the absolute score, so specifically how much money they chose to donate, or should we be looking at the proportional donation, so how much they donated out of what they received? So if we look at the absolute difference in donations between the two different groups, we might find that the £5 group donates £2.50 on average. That would be 50% of what they received, whereas people in the 30% group might donate 5%. So while that is twice as much actual money, it is only 17% of what they got. So depending on how we look at this, we would reach different conclusions regarding whether participants in the first group are the most generous, or whether it's the participants in the second group. And just for comparison, so if we're looking at the percent and in relative terms, we might find that these are similar, so that participants donated 20%, and that would only be £1 in the £5 group. But to be equally generous in relative terms, the people in the £30 group would have to donate £6. So how can we prevent these issues, or prevent the confusion of potentially getting different outcomes when using the two different kinds of measures? So often absolute values are appropriate, but when we have two different groups or two conditions that are not comparable at baseline, it might be helpful to also look at relative differences, and it might also be quite important. And some studies will use and report both absolute and relative measures. Next, we'll talk about the speed versus accuracy trade-off. When you measure performance, there is typically a trade-off between speed, so that is performing the task quickly, and accuracy, providing more correct responses. And this is especially something we need to consider in different cognitive performance measures, including things like reading comprehension, problem solving, attention, memory, and so on. And the researcher needs to decide whether speed or accuracy, or both, would be the best operationalization of capacity or performance in this specific area of research and in the specific test that they're using. Participants choose how to approach a task, so they might decide that they are trying to do it as quickly as possible, or they're trying to do it as accurately as possible. And probably they're trying to do both, but in most cases there will be a bit of a trade-off. So for example, if you get an hour to complete an exam that contains 100 multiple choice questions, would you quickly try to respond to as many questions as possible? Or would you slowly and carefully answer as many of them as you can, even if that meant that you only got through 75 of them? And we also need to consider whether there might be differences between key groups or conditions in how participants approach the task. So as an example, if we want to explore whether maths anxiety levels are associated with maths ability. So when you're measuring maths ability, are you going to look at the accuracy in the maths performance score, or will you also take into account the time taken to complete the test? Because it could be the case that maybe participants with higher levels of maths anxiety would prioritize avoiding errors. So they might complete the test more slowly because they're doing more double checking, for example. And if that is the case, then the group that's higher in maths anxiety might have higher accuracy, but they might complete the task more slowly, and they might complete fewer problems overall. Various situational factors could also influence whether participants prioritize speed or accuracy. So were they given a time limit? Do they think that they can leave the experiment earlier if they complete the task more quickly? Have they been instructed to prioritize speed or accuracy? And is the researcher in the room? This might add to the pressure of trying to do as well as possible instead of just trying to get through it as quickly as possible. And how can we prevent issues associated with this speed accuracy trade-off? So it's typically a good idea to consider both speed and accuracy. If they are both relevant, are they both measured and reported in the study? And you might also want to consider potential differences between groups of participants or participants in different conditions in how they approach the task in relation to the speed accuracy trade-off. And finally, as a more general, broader point, we can think about whether a given task measures the same thing in different participants. So you can reflect on whether there might be different strategies or approaches that people might use when presented with a task. And do approaches differ systematically between key groups and conditions? So for example, young children who haven't learned to read yet are very unlikely to rehearse word sounds phonologically or think about their meaning if you present them with written words in, for example, a memory study, whereas that would be quite an intuitive strategy for older children or adults. And participants who are subjected to negative stereotypes related to what's being measured in the study might also approach the task differently. So for example, if older adults have experienced the stereotype that their memory isn't as good as the memory of younger adults, they might be more careful and more concerned about making sure they're not making any careless mistakes in a memory study. And participants who feel uncomfortable for whatever reason might try to figure out the fastest way to finish the study, and so on. So in most situations, it is quite likely that different participants approach any experimental task that you give them in slightly different ways. So they might be trying to optimize their performance by using a particular strategy, for example. And this mainly matters if you think that people using these different strategies will affect the key result of the study in some way. Or if there are reasons to suspect that the study sample approached the task differently than the general population that the study seeks to generalize to would. how to use this in your critical evaluation. So think about whether there are any methodological or statistical artifacts in the study which may influence the reliability of the results. So you can consider if there are any floor or ceiling effects, the use of absolute versus relative differences, and the speed accuracy trade-off. And more broadly, think about whether the task is likely to measure slightly different things in participants belonging to different groups or assigned to different conditions. And if that is the case, think about how and why you think the specific artifact would influence the key results. And finally, reflect on whether the researchers could have avoided this research artifact, and if so, how could it have been avoided?